Okay, so let's continue for this problem. Okay, limit as x goes to positive infinity x times sine of 1 over x. This is a 0 times infinity form. Okay, and I'm gonna introduce two ways to do. One, let's think about a substitution way. So here's how I think. As since I have x and I also have 1 over x, what I can do here is, when x goes to infinity, I would like to introduce one intermediate variable, u equals 1 over x. And as you see that when x goes to positive infinity, then u gonna go to 0 from the right hand side, right? So this limit, let me erase this part. Equivalently, it gonna become something like this. Gonna be coming into limit as u goes to 0 from the right. Keep in mind, I let u equals 1 over x, then x equals 1 over u, right? So I have 1 over u here times sine of u. Agree? Right, sine of u. And if we reorganize this, which gonna becomes into sine of u over u. This is a perfect 0 over 0 type because u goes to 0 from the right. And we can apply the L'Hopital rule to deal with that. That is limit u goes to 0 from the right, 0 to the top, which is cosine of u over 1. And you can immediately get that this limit equals 1. Okay, so that's the first approach, first way to approach. The second way, let me erase this part, which, this is a infinity times 0 type, right? As I mentioned, we can always convert this infinity times 0 into 0 over 0 type or infinity over infinity type. So let's look at it that way. So limit as x goes to positive infinity, we have x times sine of 1 over x. Okay. So let's do it this way. Do you agree that this expression equals this, right? So sine of 1 over x over 1 over x, right? If you do flip, becomes back to here. Now let's look at it. Before it was an infinity times 0 form, but right now let's see what happens here. On the top, it is 0, right? And on the bottom, 1 over infinity is also 0. So do you see that before we have infinity times 0 in determined form, and right now we have a 0 over 0 type, right? Okay, so, and then we can apply our L'Hopital rule. The derivative of the top, cosine of 1 over x, times the derivative of 1 over x, which is negative 1 over x squared, right? Over negative 1 over x squared, right? And you see that you can simplify this into limit as x goes to positive infinity cosine of 1 over x. Because those two are identical, you can cancel them. What's the limit for this? As x goes to infinity, 1 over x goes to 0, so cosine of 0 is 1. Okay? So you see that one approach, the other approach. Okay? The first one is a little bit tricky because you need to use a substitution, but the second one is pretty basic. Okay, so that's this problem. Now let's look at another type. Okay, infinity minus infinity form. Okay, so look at this problem here. Limit as x approaches 0, 1 over sine x minus 1 over x. Okay, so we have infinity minus infinity. How do we handle this? Well, you see that inside the parentheses is a difference of two fractions, right? So why don't we combine those two fractions into one and to see what happens? Okay. In other words, let's combine those. Okay. And try to figure out the least common denominator, which is x times sine of x. So we're going to have x minus sine of x over x times sine of x. Okay. Right? So, but right now, look at what happened, guys. Okay, just a one step. Okay. Just a one step here. And you see, if I look at the structure, substitute x with 0 into this, I'm going to have 0 minus 0, which is 0. Okay, over 0 times 0, 0. So do you realize that, guys, before it looks like there's no connection at all, but after one step, which is combine two fractions into one, we have what we want, right? We have 0 over 0, the original indeterminate form, to apply the L'Hopital rule. So right now we can use the L'Hopital rule directly, which the top, which is 1 minus cosine x, right? Bottom, you're gonna use a product rule, which is sine x plus x times cosine x. Okay. Now let's see what happens. So if we plug in, guys, you see 1 minus cosine 0, which is 0 on top. Okay. Bottom, sine of 0 is 0 plus 0 times 1, which is also 0. So we still have a 0 over 0 type. What should we do? Apply L'Hopital rule again. Okay, so maybe let's write this way. So limit x approaches 0. Okay, so right now the derivative of the top is sine of x. Okay, the bottom, let's see what happens. So it's cosine x, right? Plus, again, this part you're going to apply the product rule. So which give us is cosine x plus x times negative sine x. Okay, product rule here. Now let's try to evaluate this limit to see what happens. So if we plug 0 in, you're going to have sine of 0, which is 0, over cosine of 0 here, which is 1, and then plus cosine of 0, which is 1, plus 0 times negative sine of 0, which is also 0. So as you can see that if we plug into this, that going to give us is 0 over 1 plus 1 plus 0. And mission complete, guys. We have this equals 0. Okay? So I'll stop here.